An earthquake can be compared to a water drop falling into a pool. If a faucet has a leak, water slowly accumulates as a drop. Over time, the leak continues and the drop grows in size. As it does, the drop's potential energy also increases.
In this case, the drop's potential energy is primarily dependent on the mass of the water and its height.
Eventually, the drop becomes too large to be suspended, and it falls and strikes the surface of the pool below. Energy is transferred to the water in the pool and travels outward in all directions.
Right! The energy travels as ripples on the surface of the water that we can see. However, there are also compression waves that travel outwards through the water unseen.
Like the building of the drop from the faucet, potential energy slowly accumulates in rocks inside the Earth as Earth's tectonic plates move.
In this case, the potential energy is primarily dependent on the incompressibility and rigidity of the rocks, sort of like a spring. The more deformation of the rock, the more energy it stores.
Eventually, the strain becomes so great that the rocks break and the potential energy is suddenly converted to kinetic energy.
We call this sudden release of energy stored elastically in rocks an earthquake.
Then, like ripples on the water, the released seismic energy travels outwards in all directions,
including through the Earth as seismic waves.